Okay, so this is going to be a review of Quiz 1, which everyone should have completed by now. Next week, I plan to do an overview of Quiz 2. And the reason I'm doing this is so that when it comes time to study for your cumulative final exam, that you will have these videos to go back and help you as you review, because the final exam, again, is cumulative, so you cannot learn these things just to forget it after you finish up a quiz. So problem number 1, we have a graph to analyze, and it says use the graph of f to find the given limit. When necessary, state that the limit does not exist. And they're asking us to evaluate the limit of f of x as x approaches 3. And if we look at the graph as x approaches 3, if you're coming in toward 3 from the left, notice that we passed 2 and we're getting closer to 3. What's happening to the graph? What y value does the graph appear to be approaching? Well, coming in from the left, it appears that the graph is climbing and it's approaching the value y is equal to 4. So the limit from the left of 3 is 4. And if you evaluate the limit on the right, let me change colors, as you get closer to 3, as you're coming in on the right side, getting closer to 3, notice that the graph is still climbing toward the same value, which is 4. So the limit from the left is equal to the limit from the right, and we will say that the limit is 4. Problem number 2. On problem number 2, we're looking at the limit as x approaches 2. So x is getting closer and closer to 2. Let's look at what's happening from the left. If you look at the green mark here, we're approaching 2 from the left, and we can see that the y values, or the graph, is actually approaching the value where y is equal to 4. 3 from the left, I'm coming in here, closer and closer to 3. What's happening to the graph? Well, the graph is actually getting closer and closer to what y value? We would predict that it's headed towards 6. So that's the limit. Problem number 4. Problem number 4, we have, again, piecewise defined function here. And this time they want to know, what is the limit as x approaches -2? Okay, so we're approaching -2, so that means we're coming in really tight here, moving toward -2. And notice that the corresponding graph, which is above, is climbing closer and closer to what y value? We would predict that this is going toward the value where y is equal to 1, right? The graph is climbing to the y value of 1. So that's what we will type in. Problem number 5. On problem number 5, it says that g of x is equal to x squared minus 3, and they want us to evaluate the limit as we get closer to 3, and then evaluate the limit as x gets closer to 1. Well, the first thing I'm going to do is I'm going to try to figure out which function is pictured on the right that corresponds to x squared minus 3. Well, if x is 0, then I would have 0 squared, which is 0, and 0 minus 3 is -3. So that means the intercept value for the y-intercept should be the point 0, -3. Well, this is not even a function because it fails the vertical line test. This is not a function because it fails the vertical line test. And here we have the intercept at 0, +3, so that's out. That leaves me with B, because B appears to be the correct graph. And I could look at the graph to get the answer, but in this case, I can actually plug the values straight in. For example, there's no danger of having a 0 in the denominator, right? We really don't have a denominator, so to speak. There are no square roots to worry about. 1 squared is 1, and 1 minus 3 is -2. So for the first one, I've got 6, and for the second one, I've got -2. And of course, it's graph B. We will check that, and we got that correct. Now we will move on to problem number 6. On problem number 6, I have another polynomial, right? There's no danger of a 0 in the denominator or anything like that to worry about. So I'm just going to plug -4 straight into the equation. So that's going to give me -4 squared plus 4 times -4 minus 5. And -4 times -4 is +16, but I have a minus out front, so that would be -16. And then I have 4 times -4, which is -16, minus 5 more. So that's going to be -32 minus 5 more. That would be -37 for that limit. Let's take a look at problem number 7. By the way, your quiz may have had different problems, but they are definitely similar problems. In other words, I think one quiz had x squared minus 25 instead of x squared minus 9 in the numerator, but the procedure is the same. So even though your quiz may have looked different, it was definitely similar to this one. And I noticed that x squared minus 9 is a difference of squares. And I can actually rewrite x squared minus 9 as x plus 3 times x minus 3. And I think in one of my earlier videos, I actually encouraged you to go back and review how to factor a difference of squares. And this is exactly how you would factor x squared minus 9. And notice that the x minus 3's will cancel. And now that I no longer have a fraction to worry about, the domain is unrestricted, so I can now plug 3 straight in for x, because that's the number we're approaching, and 3 plus 3 is 6. So that limit would be 6. Excuse me, problem number 8. On problem number 8, we have a piecewise function here, and we have 4 parts, and part A says, what is the limit as x approaches 2 from the left? Let's take a look at this. As we're approaching 2 from the left, we're coming in this direction closer and closer to 2, and we need to find the graph, and the graph is below as we're getting closer to 2 from the left, and notice that below the graph is actually rising to the y value of 0. So the limit is 0 for the first one. Part B says, what is the limit as x approaches 2 from the right? Well, if you get closer to 2 coming in from the right, the closer you get to 2, notice that the corresponding graph is rising and it's approaching the y value -2. So that takes care of part B. Now notice that the limit as we approach 2 from the left is different than the limit when we approach 2 from the right. So the limit in general does not exist. And finally, on part D, they want to know what is f of 2. In other words, if x is 2, what is the y value? Well, notice that this dot here is not filled in, so we can't use that. X is equal to 2 on this dot here because this one is filled in, and notice that the y value there is 0. So let's go ahead and put those in. 0, negative 2. Does not exist, and 0. Number 9. Number 9 is asking if this piecewise defined function is continuous. It's continuous if it doesn't have any breaks. And the only place where we are in danger of having a break is when x takes on the value 2. So let's see what we have here. I've got a line. Let me draw this. This is going to be a very rough sketch because of this mouse. But anyway, I have a line of slope 3, intercept negative 3. So I'm going to claim that it goes through here at 0, negative 3. And if x is greater than 2, we're on that line. So it's going to be, you know, oops, I made a big mistake, didn't I? Let me clear this out. I apologize. I was not paying attention to what I was doing. So I'm going to graph the line of slope 3, intercept negative 3, but it's only on that line starting at 2. Well, 3 times 2 is 6, and 6 minus 3 is 3. So 2, 3 would be on this line here. And it has a slope of 3, so it's going to go up like this, let's say. And then if x is less than or equal to 2, by the way, that one is defined only for x is greater than 2, so let me leave this hollowed out because it says greater than, not greater than or equal to 2. But if x is less than or equal to 2, then you're on this line here, which is a line of slope 1/2, intercept at 1. But notice if I plug 2 in, I get 1/2 of 2, which is 1, and 1 plus 1 would be 2. So 2, 2 would be the point. And I'm going to fill this one in since it says if x is less than or equal to 2. It's going to be a line of slope 1/2 going through the y-intercept at 1. And again, this is a very crude drawing, but it looks something like this, let's say. And notice that at 2, we have a jump. We have what is known as a jump discontinuity. So therefore, this function is not continuous. There's actually a break when you get to 2. You actually jump tracks. You go from one function to the other. So let's look at our options. The given function is continuous. It can't be this one. The given function is continuous for C. It can't be that one. So let's look at options B and D. B says the given function is not continuous at x is equal to 2 because f of 2 does not exist. Well, that's not true. F of 2 did exist. In fact, when I plugged 2 in, I got 2. So f of 2 is 2. Can't be that one. So we've already determined out that they give us a, and they want us to find a simplified form of the difference quotient for part A. So let's do that. The difference quotient is actually f of x plus h minus f of x all over h. And this is our function, of course. So let's go ahead and write this out. F of x plus h is going to be negative 4 And where I see x, the variable, I have to plug in my new domain value, which is x plus h. And it's raised to the power of 2 because that's what they give us in the problem, right? Negative 4 times the domain value squared. So I have negative 4 times the domain value squared. So that's f of x plus h. And then I have to subtract from that f of x, which is actually negative 4x squared. But I can't forget that I have to divide all of this by h. Now, if I take x plus h and square it, that's the same thing as x plus h times x plus h. And that's going to give me negative 4x squared minus 8xh minus 4h squared plus 16x squared. I'm sorry, plus 4x squared. And this is still all over h. So you may be thinking, how did you get all of that? Well, again, I multiplied x plus h times itself. That's going to be x plus h times x plus h. And then I can FOIL this, or I can use the box method, whichever method you prefer. And that's going to be x squared plus xh plus xh, that's 2 xh's, plus h squared. But then I have to multiply this negative 4 here times all of that. Notice that the negative 4x squared and the positive 4x squared, if I add those together, I get 0. And then I can divide h into the two terms above it, and that's going to give me a final answer of negative 8x minus 4h. And of course, if we were evaluating the limit as h approaches 0, this would actually disappear, and I would be left with negative 8x, which happens to be the derivative of negative 4x squared. Okay, so this is the answer to part A. And then they want us to use that information to figure out the answers to the rest of it. So let's see. If x happens to be 5 and h happens to be 2, well, I can go back in and just plug those values in here. So let's see, negative 8 times 5 is negative 40, minus 4 times h would be 4 times 2, which is 8. And negative 40 minus 8 appears to be negative 48. All right, that should take care of the first one. What about if x is 5 and h is 1? Let's do this one here. Well, if x is 5, negative 8 times 5 gives me, again, negative 40. But this time, h is equal to 1. And if h is equal to 1, that's going to be minus 4 times 1, which is minus 4. And negative 40 minus 4 is negative 44. And let's look at the next problem. This time x is 5, but h is 1/10. Okay. So if x is 5, that's going to be negative 40 minus 4 times 1/10. Well, 4 times 1/10 is 4/10. That's going to be 0.4. So it looks to me like the answer on that would be let's see, negative 40.4. I hesitate doing these things in my head because sometimes I get a little ahead of myself, but we'll check these, of course, and we'll fix anything that's not right. So that looks good on that one. And finally, let's look at what happens when we have 5 for x and 1/100th for h. So that's going to be negative 40 minus 0.04. So that means you'll go back 40, back 4/100ths. So to me, that should be negative 40.04. Okay. So let me type all of these things in. We said that the answer for A is negative 8x minus 4h. And we said the answers on part B would be negative 48, negative 44, negative 40.4, and then negative 40.04. And let's cross our fingers and make sure we got this correct, and we did, so we're good. And let's move on to problem number 11.
This isn't right.
Okay, so number 11, it's the exact same scenario. They've just changed the function. And let's see what we have. It says to write the difference quotient again. So that's going to be 2 times x plus h squared minus 2 times x plus h plus 2. So there's f of x plus h, but then I have to subtract f of x. So that's going to be minus 2x squared plus 2x, because a minus and a minus is a plus. And then I have to subtract 2. And of course, we still have to divide all of this by h. If I FOIL this, x plus h times itself, and then multiply by 2, that should give me 2x squared plus 4xh plus 2h squared minus 2x minus 2h plus 2 minus 2x squared plus 2x minus 2. And it looks like my computer is going to take a break. Let's see. Plus 2x minus 2 all over h. Now this is what I like about the difference quotient. If we do it correctly, a lot of things should cancel out in the numerator. For example, I have 2x squared here, which would take this 2x squared out, because 2x squared minus 2x squared is 0. Also, notice I have a negative 2x and a positive 2x here. That will 0 out. And I have 2 minus 2, which leaves me, if I divide h into every term in the numerator, that leaves me 4x plus 2h 4x plus 2h minus 2. And if we were evaluating the limit as h approaches 0, this would actually drop out. And that would leave us 4x minus 2, which happens to be the derivative here. But that's not what they asked us to do. So this is the answer for part A. And now we have to figure out, using this, the answer to part B. Well, part B says, on the first row, that x is 6. If x is 6, 6 times 4 is 24. It says h is 2, so add 2 times 2, which is 4, and then subtract 2. That's going to leave me 28 minus 2, which should be 26. And if we go to the second row, x is still 6, so that's going to give me 24. But this time, h is 1, and I'm going to add 2 times 1, which is 2. I'm still going to subtract 2, and that's 24. The next row, we still have 4 times 6 because x is still 6. That's going to be 24. And h is now 1/10. So let's see if I can do this. 2 times 1/10 is going to be 2/10. So that's going to be plus 0.2. And it looks like my computer wants to freeze up again. Let's see. Plus 0.2, and then I have to subtract 2. And again, here we go. Let me think about this. I've got 24 minus 2, which is 22. 22 plus 0.2 should be 22.2 if I did that correctly in my head. And again, we'll check this momentarily. And finally, the last row. X is still 6, so that's going to give me 24 here. And I'm going to add to that 2 times h. This time h is 1/100th. So that's going to give me... I just realized there's a mistake on the previous problem. We'll fix that. But anyway, I've got 2 times 100th, which is going to be 0.02. I misread this. This should actually be a decimal. So not a subtraction sign, so we'll fix that. And then I believe we'll still subtract off the 2. So let's see, that is going to be 24 minus 2. That would be 22. So 22 plus 2 cents, right? Would be $22.02, let's say. We'll do it that way. Now let me go back and look at that third one. I've got 24 minus 2, which is 22. No, I did it correctly. So 22 plus 0.2 would be 22.2. I think we're good, actually. Okay. So let's put the answers in and see what happens. For the difference quotient, we figured out the answer is 4x plus 2h minus 2. And using that information, we got the following answers, right? We got 26, we got 24, we got 22.2, and we have 22.02. So let's check these. Okay, so far so good. Okay, and finally, problem number 12. Okay, problem number 12, I would make this a calculator exercise and just do it that way. So I'm going to use my calculator, and I typically type 90 miles per hour on the calculator, so I hope I get this correct. If not, no big deal. We'll go back and fix it. But this is our function p of x. And the first question is, what is p when x is 5? So all I have to do is go back and plug in 5 for x. And let's see what that is. That's going to be 0.03 times 5 squared, which is 25. Then I will add to that 0.57 times 5. And then I'll add 5.99. I got 9.58. So let me put that in there. I'm sorry, 9.59. I wasn't paying attention. Okay, 9.59. Part B says, what is P when X is 15? So now I'll go back into the original equation. I'll plug in 15 for X. So that would be 0.03 times 15 squared plus 0.57 times 15. And then I will add 5.99. On that one, I got 21.29. And part C says, what is P of 15 minus P of 5? That just means I'm going to do 21.29 minus 9.59. And that gives me 11.7. And then I'm going to take that answer and divide by 15 minus 5, which is 10. So if I take 11.7, if I divide that by 10, that's going to move the decimal place over to the left 1. That's going to give me 1.17. Okay, so that takes care of the math. And then we have, which of the following is the appropriate interpretation of this result? Well, if you look at the problem, it says, let me change colors here. The problem says X is the number of years after 1991 and P of X is in dollars. So these are all dollar values, right? $9.59, $21.29, $11.70, and then $1.17. That's what we have here. Okay. So P of 5 would be 5 years after 1991, and that would be 1996. And then if X is 15, that would be 15 years after 1991, and that's going to be 2006. So those are definitely the years we're working with here. Okay, so it looks to me like we can probably rule out B and C. Let's check. B says this amount was the average price difference of a baseball ticket from 90, oh, I don't know. I'm not going to rule that out yet. Let's go through all of these. Part A, from 1996 to 2006, the price of baseball tickets increased by this amount per year. Well, let's think about what P of 15 minus P of 5 would represent. P of 15, which is 2006, right? This is the average price of a ticket to a baseball game. So the average price in 2006, which would be P of 15, would be $21.29. Okay. And P of 5, which we said is 1996, that's just what, 10 years earlier? The average price for a baseball game back then would be P of 5, and that would be $9.59. So pretty good increase there. So we'll just say $9.59. Okay. I'm just going to graph this. I'm going to draw a straight line. Actually, it's not straight because this is a quadratic. It probably looks something like this. Probably curves up like that, we'll say. But anyway, we'll let this very crude sketch represent the average price of a ticket to a baseball game in those years. And if you look at the $1.17, what does that represent? Well, the 15 minus 5 is going to be the difference in the years, right? There's a 10-year difference between 2006 and 1996. And then we know that P of 15 minus P of 5 is actually going to be this drop here. Okay, so from 1996 to 2006, the price of baseball tickets increased by this amount per year. Okay, that's part A. So did the prices go up? Did the price go up $1.17 a year? That's the question. Looks good to me. Let's check the other two. This amount was the average price difference of a baseball ticket from 1996 to 2006. Well, that would be this horizontal line here. That would be the price difference from those 2 years. Part C says the result tells us that the price of a baseball ticket in 2016 is the amount more than in 2006. Well, that may be true, but the graph didn't really tell us that. Or I should say the math did not tell us that. So part D, from 1996 to 2006, the average price for a ticket increased on average by this amount per year. So what do we think the answer is? Do we like on average? Or do we like increased by this amount? Well, remember, even though the graph is quadratic and it's curved in red, since we're only looking at 2 points, that's going to give us the slope, right, between these 2 dots here. And that's going to be the average change in price over 10 years. So I like part D. Okay, so there we go. Now again, your quiz may have looked slightly different. I think the numbers were changed, and there are probably 3 or 4 different versions, maybe even more versions out there that I'm aware of. But anyway, this is essentially how you would solve these types of problems. And I'm sharing this video with you again so that when you go back and study for that final exam, you'll have this video to fall back on. And I plan to release a video for all of the quizzes. So next week, we will have the video for quiz 2. Thank you.